have an ordinary piece of rope. It's not one of those magician's ropes that can mysteriously be put back together once it's been cut in half, and it's not particularly strong or durable. But you might say that it does have special powers because it's going to demonstrate for us the physics of traveling waves. Ropes and strings are really good for this kind of thing because when you move them back and forth, the movement of your hand travels through the rope as a wave. By observing what happens to this rope when we try different things with it, we'll be able to see how waves behave, including how those waves sometimes disappear completely. How's that for a magic trick? This is a typical wave, and waves form whenever there's a disturbance of some kind. Often when something about the physical world changes, the information about that disturbance gradually moves outwards, away from the source in every direction. And as the information travels, it makes a wave shape. Think about the disturbance you cause, for example, when you jump on a trampoline. When you hit the trampoline, the downward push that you create moves the material next to it down a little bit too. And the same goes for the material next to that, and so on. And while that information is traveling outward, the spot where your feet first hit the trampoline is already recovering, moving upward again because of the tension force in the trampoline. And that moves the area next to it upward too. This up and down motion gradually ripples outward, covering more and more of the trampoline. And the ripples take the shape of a wave. Waves are made up of peaks with crests, the bumps on the top, and troughs, the bumps on the bottom. They have an amplitude, which is the distance from the peaks to the middle of the wave. They also have a wavelength, which is the distance between crests, a full cycle of the wave, and a frequency, which is how many of those cycles pass through a given point every second. Multiply the wavelength by the frequency and you get the wave speed, how fast it's going. And the wave speed only depends on the medium it's traveling through. That's why the speed of sound, which is a wave, doesn't depend on the sound itself. It doesn't matter how loud or quiet it is, it just depends on whether the sound is traveling through, say, air or water.